You have seen a black hole before, not in real life. In a movie, in a science documentary, in a computer-generated animation, where space bends and stars spiral into darkness, and everything gets stretched like taffy until it vanishes. You have seen the pictures. The glowing orange ring, the perfect circle of shadow in the center. The first real photograph of a black hole, released in 2019. The one that broke the internet for a day, because humanity had finally seen the unseeable. But here is what those images do not show you. They do not show you what it feels like to be near one. They do not show you the silence. They do not show you the moment when the rules of reality stop applying, when time itself begins to break, when the universe says no and pulls you past a line you cannot see and cannot cross back over. That line has a name. It is called the event horizon, and it is the edge of everything. Not the edge of space, not the edge of the galaxy, the edge of cause and effect, the edge of information itself. Once something crosses the event horizon of a black hole, it is gone. Not destroyed. Not hidden. Gone in a way that is more final than death, more absolute than any ending you can imagine. No signal can escape. No light can return. No message can be sent. It is a one-way door into nowhere. And on the other side, the universe does not care what you were or what you knew, or whether anyone will miss you. You simply stop being part of reality. Now here is the part that should terrify you. Black holes are not rare. They are not exotic. They are not some strange cosmic accident that only exists in distant galaxies we will never visit. There are millions of them in our galaxy alone. Maybe billions. We cannot see most of them because they do not glow. They do not announce themselves. They are invisible wounds in space, silent and patient, waiting. The nearest known black hole to Earth is about 1,600 light-years away. That sounds far. It is far. But in cosmic terms, it is close. Uncomfortably close. Close enough that astronomers catalog it. Close enough that we gave it a name. Gaia BH1. And there are probably others we have not found yet. Closer. Quieter. Hiding in the dark between stars. But distance does not matter, because the question is not whether you will ever encounter a black hole. The question is, what would happen if you did? What happens when you reach the edge? What happens when nothing, not even light, can escape? Let us start with something you already understand. Gravity. You feel it right now. It is pulling you down into your chair, holding you against the floor, keeping your feet on the ground. Earth's gravity is strong enough to hold you. Strong enough to keep the atmosphere from floating away. Strong enough to keep the moon in orbit 384,000 kilometers above your head. But compared to a black hole, Earth's gravity is nothing. Imagine this. If you wanted to escape Earth's gravity completely, to leave the planet and never come back, you would need to reach a speed of 11.2 kilometers per second. That is about 40,000 kilometers per hour. Fast, but not impossible. We have built rockets that go that fast. We have sent probes beyond the solar system. We have left Earth behind. Now imagine a black hole with the same mass as Earth, same weight, same amount of matter, but compressed. Not compressed a little. Compressed so much that all of Earth's mass, every mountain and ocean and city and atom, is squeezed into a sphere the size of a marble. About 9 millimeters across. At that density, the escape velocity at the surface would not be 11.2 kilometers per second. It would be 300,000 kilometers per second. That is the speed of light. And nothing in the universe can go faster than light. Not rockets. Not radio waves. Not information. Not anything. Which means, if you were standing at the surface of that marble-sized, Earth-mass black hole, you could not leave. You could not send a signal. You could not shine a flashlight. You could not shine. You could not shine. You could not shine. The light itself would curve back down into the black hole and vanish. That marble-sized sphere is the event horizon. The edge. The point of no return. And here is where it gets worse. Real black holes are not the mass of Earth. The smallest black holes we know of are about 3 times the mass of the Sunday. The event horizon of a black hole like that would be about 18 kilometers across. Not a marble. A small city. And if you were standing on Earth, looking up at the sky, and a black hole that size suddenly appeared above you, you would not see it coming. You would see the stars around it bend. You would see light curve and twist and spiral as space itself warped. And then, in the final seconds before it touched the surface, you would feel the pull. Not like falling, like being stretched. Because gravity does not pull evenly. The closer you are to the source of gravity, the stronger it gets. If you fell feet first toward a black hole, the gravity pulling on your feet would be stronger than the gravity pulling on your head. Not a little stronger. Exponentially stronger. Your body would stretch. Your bones would crack. Your cells would tear apart atom by atom in a process physicists call spaghettification. You would become a stream of particles, and you would cross the event horizon, still conscious, still aware, for a fraction of a second, before your brain stopped being a brain and became a smear of atoms falling into the singularity, the infinitely small point at the center where all the mass of the black hole is concentrated. But here is the truly strange part. From your perspective, falling in, time would feel normal. You would not notice anything unusual about the passing of seconds. But to someone watching you from far away, outside the black hole, time would slow down. Not metaphorically, literally. The closer you got to the event horizon, the slower you would appear to move. Your clock would tick slower. Your heartbeat would slow. Your signals would stretch and redshift into longer and longer wavelengths until, at the exact moment you crossed the horizon, you would appear to freeze. You would never seem to cross the line. You would hover there forever, asymptotically approaching the edge, but never quite reaching it. Your image growing dimmer and dimmer until you faded into the darkness. But you would already be gone. You crossed the horizon. You fell in. You stopped existing in the universe we can see, and nothing you experienced beyond that edge can ever be known. Because information cannot escape a black hole. Not even in theory. Once something crosses the event horizon, it is removed from reality. The universe forgets it. Every particle, every photon, every signal that made up your body gone, erased, cut off from causality itself. This is not science fiction. This is Einstein's equations. This is the mathematics of general relativity, tested and confirmed 1,000 different ways. Black holes are real. Event horizons are real. And the edge is absolute. Now let me make this worse. The black holes I have described so far are small. Stellar mass black holes, formed when massive stars collapse. But there is another kind. Supermassive black holes. The monsters at the centers of galaxies. Our galaxy, the Milky Way, has one. It is called Sagittarius A, and it sits 26,000 light-years away at the galactic core. Its mass is 4 million times the mass of the Sunday. Its event horizon is 24 million kilometers across, about 60 times the distance from Earth to the Moon. If you replace the Sun with Sagittarius A, the event horizon would swallow Mercury and stretch halfway to Venus. And it is quiet. It is not feeding. It is not devouring stars. It is just sitting there in the dark, spinning silently, bending space around it like a stone bends a rubber sheet. But it will not stay quiet forever. In about 4 billion years, the Milky Way will collide with the Andromeda Galaxy. The two supermassive black holes at the centers of those galaxies will spiral toward each other, orbit each other, and eventually merge. When they do, They will release more energy in a single second than all the stars in the observable universe produce in a year. That energy will ripple across space as gravitational waves, literal vibrations in the fabric of space-time itself. We will not be here to see it. Humanity will be long gone, but the black hole will remain. Larger, hungrier, still spinning in the dark, still waiting. There is something unsettling about black holes that goes deeper than the physics. It is not just that they are dangerous. It is not just that they destroy everything they touch. It is that they represent a limit, a boundary, a place where knowledge ends. We pride ourselves on understanding the universe. We split atoms. We mapped the human genome. We sent robots to Mars and probes to the edge of the solar system. We built machines that can predict the motion of planets a million years into the future with perfect accuracy. But a black hole says no. It says there are things you will never know. There are questions you will never answer. There is a line you cannot see past. And once something crosses it, that information is lost forever. Not hidden, not encrypted. Lost in a way that violates everything we thought we understood about how information works. Stephen Hawking spent decades wrestling with this. He proved that black holes are not completely black. They emit a faint radiation, now called Hawking radiation, because of quantum effects near the event horizon. Over trillions of years, this radiation causes black holes to evaporate. They shrink, they lose mass. Eventually, they vanish. But here is the problem. Hawking radiation is random. It carries no information about what fell into the black hole, which means when a black hole evaporates, everything that ever fell in every star, every planet, every particle, every piece of information is gone. Erased. Destroyed in a way that should be impossible according to the laws of quantum mechanics. This is called the black hole information paradox, and we still do not have a complete answer. Some physicists think the information is encoded on the event horizon itself, smeared across the surface in a way we do not yet understand. Others think it leaks out slowly in the Hawking radiation in patterns too subtle for us to detect. Others think the paradox reveals a flaw in our understanding of space-time itself. But no one knows. And maybe that is the point. Maybe black holes exist to remind us that the universe does not owe us answers, that there are edges we cannot cross, questions we cannot resolve, mysteries that will outlast our species and our science, and every theory we ever construct. But here is the strange thing. We are not afraid of black holes. We are drawn to them. We point our telescopes at them. We build detectors to listen for the gravitational waves they create when they collide. We spend billions of dollars photographing them, studying them, trying to understand them. Because humans do not run from edges. We walk toward them. We stand as close as we can and peer over the side, even when we know we will never see the bottom. That is what Voyager was. That is what the Apollo missions were. That is what every telescope and every particle collider and every deep-sea submersible is. We build machines to reach the edges of the unknown, not because we expect to conquer them, but because standing at the edge and looking into the dark is the most human thing we do. Black holes are the ultimate edge. They are the place where reality ends and the unknown begins. They are proof that the universe is bigger and stranger and more unforgiving than we will ever fully comprehend. And yet we keep looking. One day, maybe centuries from now, maybe millennia, humans or whatever we become might build a probe and send it toward a black hole. Not to destroy it, not to escape it, just to see, to send back data for as long as possible, to measure the warping of space, to watch the clock slow down, to transmit a final signal before crossing the horizon and vanishing forever. And maybe, in that final transmission, we will learn something new, or maybe we will learn nothing. But we will have reached the edge. We will have touched the place where nothing, not even light, can escape. And for one brief moment, we will have stood at the boundary of everything and looked beyond.